Greetings to all. This is Ranjini working as an assistant professor in the Department of Computer Science and Engineering at RMD Engineering College. In this lecture, we can see about a linked list. Linked list is a linear data structure that includes a collection of nodes. Here, each node stores the data and the address of the next node. Each element in the list, we call it as a node. So, look at the picture here. This particular part, we call it as a node. And each node has two elements. One is the data and next is the address of the next node. So here how we represent. So what is a linked list? Linked list is also as like array. Linked list also shows the collection of similar data element. But the difference is in array we store the data in a contiguous memory location. But here that's not the scenarios. Here I can store the location. Suppose I am going to store a data 10. First data is 10 and I am storing the 10 in the memory location 100. And if I want to store the next data, it's not this I have to store next to 10. I can store wherever the space is available, I can store the next data. But how will I make the connection? How will I identify the next node? Next node is by using this address. So in this particular node, this position, next position holds the address of the next node. Suppose the next data I'm storing at the memory location 200 means I have to, in this particular space, I have to represent using, I have to mention as 200. So this is the representation of linked list. So each node has two elements. That is, one is the data item, other is the address of the another node. Look at the example picture here. This is a node, first node. Here I am storing 10 is the data which I have to store. And I'm storing 10 in the memory location 5001. And the next one is 5021, which is the address. So next element is available at the memory location 5021. So next data at the 5021 I have stored 40. So here for the data is 40 and 5014 represent the next data where my next data is available. So look at the last node I am representing the address position here null is represented, which mean I don't have any other nodes. Only 4 nodes I have declared in this particular linked list. So since I don't have any other nodes, so I am representing in that particular position, we are representing as null. So now let's look at the advantage of linked list over array. First, it is dynamic size. Now look at the array. In array, suppose if I want to initialize the array, while initializing the array itself, we have to mention the size of the array. Suppose imagine I am giving the size of array to be 50. So in the memory location, what happens is the entire 50 space will be allocated for the array. But I'm only storing 5 elements into an array. So what happens is I'm using only 5 elements. I'm using only 5 memory space, but the entire rest of the 45 memory space is getting wasted. So, but in linked list, this is not the scenario. I don't want to mention the size. Dynamically, I will allocate a size. If I want to insert one more node, means at the time of insertion, I'll search for a space where the space is, suppose imagine I'm having 2 nodes. How this address will be calculated is suppose it's an integer. This is the integer value and this particular size of the integer value is 2. So 2 plus 2, 4 memory location I will allocate for this particular memory node. So if I'm inserting, already I have inserted 4 nodes. Now if I want to insert the 5th node, means wherever this 4 memory space is available, I'll allocate a space for the particular in this linked list. But in array, that's not the scenario. I have inserted 100 elements. I have specified the array size to be 50 and I have inserted 50 elements. Now I need one more element. So if I'm increasing the array size to be 51, already the next space is allocated. Means what happens is a new 51 space will be allocated for the array. So this is the main disadvantage over of array compared with linked list. Now next is the efficient for insertion and deletion. Memory is very efficient and it is easy to implement and very efficient in by performing sorting operation. The next one is the application of linked list in our real world. Image viewer. Suppose I want to view the image one after the other. So what we can do is we can use the linked list concept. First, in the first data space, I'll store the image and the next data space, I'll store the address of the next image which I have to view. And the next in the web browsers, we use a previous and next button. This button we use implemented using the linked list concept and music player to move on to the next music and GPS navigation. All those things we are using linked list. This is the types of linked list. There are four types of linked list. One is the singly linked list, doubly linked list. Third one will be the circular linked list, and finally it's circular doubly linked list. Singly linked list is nothing but a normal linked list. In a linked list we have a two element. One is the data. A node has two elements. One will be the data, other will be the address of the next node. So here 2 is the data which we have to store in the particular memory location. So what is 100 means is my next data is available at a memory location 100. So here I have represented 104. So my next position, next data is available at the position 108. And in the last position I am representing as null, which means I don't have any other data. So I am representing that particular position as null. Next is the doubly linked list. In doubly linked list, we have a node has three elements. One is the address of the previous previous node. Second one next will be the data, and next will be the address of the next node. So look at the first node. Since it is the first node, I don't have any other previous node. So in the particular previous position, I am representing as null. So next, this particular part is the data part. And finally 100, which means I am having the next data is having at the memory location 100. And look at the second node. The second node, the previous part I'm mentioning is 96, which means my previous data is available at the memory location 96. Data part, the data is 3, and next 104. The next element is available at the memory location 104. Next, third type is circular linked list. Circular linked list. Circular linked list, which means in this normal singly linked list, there is after the last node, the null is represented in the particular position, which means this is the last node. But in the circular linked list, what is the scenario is the last node will be connected with the first node. Okay, the last node will be connected with the first node. So in the in the particular tail part, the last address position I'm mentioning is 96. So last node is getting connected with the first node. That is a difference. Now let's see the circular doubly linked list. The same scenario. So last node should be connected with the first node. So in the address position, initially for normal doubly linked list, in the previous position we mentioned as null. But here we are mentioning as 104, which means the last node address is 104. So we are mentioning as 104. So 100 is the data where the next element is stored. So as like here also we are representing 96, which means the previous data, 104 the next data. Look at the third node here, 100. 100 is the previous data, where previous data is 3. So in the particular previous position, in this particular position, we are representing the address 100. And next is the data part, and this finally it will be a connection to. So since it's a circular doubly linked list, the last node has to be connected with the first node. So in this particular position I was representing the address 96. So this last node is getting connected with the first node. These are the 4 types of linked list. And thank you for watching the video. In the next video we can see the implementation part of the linked list.